All right, this function, negative 16x squared plus 64x plus 5, that is the height model. You should recognize the vertical height or the vertical motion model in feet per second or in feet instead of meters. This models the height of a watermelon from a watermelon launcher, even though it looks like a pumpkin. Anyway, so from a watermelon catapult thing, it shows the height. So negative 16x squared plus 64x plus 5. We want to know, when will the height of the watermelon be 20 feet? Okay, so when will x, or when will f of x equal 20? And we want to find what our x value is for that. Okay, so what we're going to do is we're going to say f of x equals 20. We're going to rewrite our equation as 20 is equal to negative 16x squared plus 64x plus 5. And to use the quadratic formula, we need this to equal 0. So we're going to subtract 20 from both sides. And we get 0 is equal to negative 16x squared plus 64x minus 15. And so now we have our A, our B, and our C. And we're going to write our quadratic formula. So negative b, that's what we start with, so negative 64, plus or minus the square root of b squared. This is why they invented calculators, because I do not know what 64 squared is. 4,096. 4,096 minus 4 times negative 16 times negative 15. So that's minus 960, it looks like. All divided by 2 times negative 16. So negative 32. Okay, 4,096 minus 960 is 3,136. So negative 64 plus or minus the square root of 3,136 all over negative 32. I'm just going to go ahead and take the square root of that. Oh, and it's a perfect square. How nice of them. So we have negative 64 plus or minus 56 all over negative 32. All right, so let's do negative 64 plus 56 over negative 32. Negative 64 plus 56 is negative 8 divided by negative 32 is 0.25 seconds. And then the last one, negative 64 minus 56 over negative 32 is 3.75 seconds. And that should make sense, right? Because we're not looking for when it hit the ground. We're looking for when is it at 20 feet. Well, it has to pass 20 feet twice. It has to pass it on the way up. So here's our watermelon. It's going up and coming back down. And we'll just say that right about here is our 20-foot mark. And so it has to pass it right here on the way up and right here on the way down. And if we were to come down here, this would be 0.75 seconds. And then over here, this would be 3.75 seconds. And actually, from that information, you should be able to find the time for the vertex, or our axis of symmetry. Should be 2.25. And so that means that we have 1.5 seconds in between each one. Anyway, that's based off of symmetry. That's not necessarily needed information for you. You could use that to find out what the maximum height is of the launch, but that's kind of beside the point. I'm probably going to do that just because I like to find stuff like that. But you don't have to. You could probably stop watching the video now if you don't want to. I'm going to plug in 2.25 into f of x. So f of 2.25 is equal to negative 16 times 2.25. We could just use our vertex formula as well. Plus 64 times 2.25 plus 5. That first 2.25 is squared. Okay, so I'm plugging that into a calculator. 2.25 squared times negative 16 plus 64 times 2.25 equals plus 5. And so f of 2.25 gives me 68 feet. So in 2.25 seconds, it reaches the vertex, and the vertex is at 68 feet, which means I drew that 20-foot line in completely the wrong place. But that's okay. So, I mean, just picture what would happen if you look up and 68 feet in the sky, there's a watermelon flying over your head. It's fun to imagine. If you ever watch the Discovery Channel, I think it was, used to do a pumpkin chunkin or chuckin. They'd launch these pumpkins out of catapults and things. And so now you're going to be like, oh, I really want to watch that so I can calculate the quadratics of it, I'm sure. Anyway, that's enough for that one.